5.1, use properties of exponents.
Sorry, I just found out that I did something. Am I doing it?
There it is.
Okay.
Alright, evaluate the expression, tell which properties of exponents you used. We are not doing that, we're just evaluating them.
That was really slanted.
4 to the negative 2, all cubed. So we have a power raised to a power, we multiply the exponents, so this would be 4 to the negative 6. Then I can't leave it that way, so I need to move it to the bottom, so this would be 1 over 4 to the 6th. And I'm content with you leaving it there.
Oh, the negative exponents.
I'm not expecting you to multiply out 4 to the 6th.
Perfect.
If it's stuff that you should know, like, obviously, you should do it, but this isn't something you would know.
Algebra 1 is 11. What grade is Algebra 1?
8.
Oh.
Alright, 2 to the 4th, all squared.
With Brody, right?
No.
No, Brody's in like 1B.
He's still in algebra.
Alright, 2 to the 4th squared. We multiply the exponent, so what do I get?
2 to the 8th.
He swears he's gonna do geometry also.
You're such a smart cookie.
Thanks.
Good.
Now, 2 to the 8th, you should be able to do that one.
2,
Unless you actually
2, 4, 8, 16.
32.
No, just keep going.
I'm stuck at
Isn't it
64.
128. Yeah, good job, Clara.
256.
Why did you go? You're such a smart cookie.
That one should be an easy one for you to multiply.
Still count with my fingers.
Well, I do that if I'm, like, figuring out how many things so that I don't miss
I do it
one
all the
for
I was
that,
doing that
but...
during the math test. I was like,
I
okay,
do it
minus
during math
7.
test.
Yeah.
I'm like,
8, 3/5 raised to the 4th.
I don't walk, I bet.
Oh, so it's 3, 4
So 27
over 5 fourths.
27 over.
Yep.
Yeah.
3 to the 4th over 5 to the 4th.
Unless you just do like
Now, you should know what 3 to the 4th is.
27.
Nope.
Oh.
3 times 3. 9. Times 3.
It's after
80.
that.
Oh yeah.
27
I'm sorry.
times 3.
That's massive stupid on my part.
81 over. This would be the same as 25 times 25.
Hold on. Give me like 5 seconds. It's gonna be more than 5.
Come on, is this it? Is this it?
625?
oh yeah.
Why are you saying oh yeah like you did?
No, because like,
Oh yeah.
no.
It sounds right.
Yeah.
Yeah, that sounds like what?
Like what?
It sounds right.
It does. Like, yeah.
10. 9 cubed times 9 to the negative 1. What do we do with the exponents in one like this?
Adam.
Add them.
Add them together. So we get 9 what?
9 to the second. 9 squared.
Yep. Which is
81.
I am so mean to me.
He's proud.
What? Oh!
12.
I'm looking Jonah from.
2/3 raised to the negative 5 and 2/3 raised to the 4th.
Okay. So do you distribute it into the fraction?
I wouldn't do that yet.
Oh.
These have the
negative-
same base, so I would combine them just like we did in 10. So I would have 2/3
-1,
to the negative 1.
which is a good question because it's a fraction instead of a fraction.
What?
Well, we
'Cause you
put it where it ain't, make it positive. So that means we would put like the negative 1 on the 2 and the negative 1 on the 3, and then we'd have to swap them. Or because this is on the whole fraction, I can just flip my fraction and it's 3/2.
Oh,
Oh,
that's
yeah.
it.
And then if it was something other than 1, we obviously would need to
Boom, shakalaka.
do it. But I like to move my stuff around first to get to the positive exponent before I do anything else.
Pretty good.
14.
Yeah.
1/2 raised to the -5 raised to the 2.
I don't know.
Whoa.
I look
Okay.
way first.
Parentheses and stuff.
You have a power raised to a power, so what do we do?
You
Multiply.
you
Multiply.
multiply them, so it's -10.
So 1/2 to the -10. If I have a fraction being raised to a negative exponent, I just flip the whole fraction.
So it should be 2.
So 2 to the 10.
So 2 times 2 is 14, 8, 16.
Well, we said up here 2 to the 8th is 256, so you could just keep multiplying that. But I wouldn't, that one's,
6,
you could leave that
12.
one, I don't care.
Okay, just keep going.
6, 12.
Times 2.
1,224.
It's
clue.
1024, but
Ew.
if you wanted to know, I wouldn't make you do this one necessarily, but 1024 is what that would be.
Yeah, 'cause it's like the, because it's like bits.
Bits and pieces.
1 bit, 2 bit, 4
All right, the next thing is scientific notation.
Oh, wait,
What
no.
is this again?
I
The
forgot
back of my paper is bled through.
Science.
Isn't this where you have to add the zeros and
Yeah, it's just
subtract
where you move the
zeros?
decimal point
forgot
a
this.
bajillion times.
What is this?
It's where you move the decimal point a
I was good at
bajillion
this.
times.
16. 1.2 times 10 to the -3 times 6.7 times 10 to the -7.
0.2.
So it'd be.
So, the way we do these is we combine the stuff that's the same, okay? Everything is getting multiplied here. So, I have a 10 to the -3 and a 10 to the -7. So, this is going to give me, add the exponents, 10 to the -10. Now I just need to multiply 6.7 times 1.2.
Oh, you know, that's a lot smarter.
I need to know this.
And when you do that, we move the decimal place twice, so 8.04 times 10 to the -10.
Oh.
Yeah.
Now, if the decimal place was not just after the first number, because scientific notation has to be after the first number, then I would need to move it and then move this around accordingly. But
Oh, you
this
see
one,
that
I didn't
at-
have to do anything else. What?
You just leave it at that. You don't do like the super small decimal point.
The super small decimal
Or
point.
is that not what this is?
This is scientific notation.
No. Yo, be quiet.
Jenny, you're having a hard day with your pimple patches.
18.
Swear
7.2
this-
times
Fine.
10.
Sure.
You just leave the whole sheet in there.
Someone that forgets their layer.
They're a liar?
We can have a quiz if we're ready. Okay. 7.2 times 10 to the 9th times 9.4 times 10 to the 8th. So just like on the last one, I'm going to combine the 10 to the 9th and the 10 to the 8th. What would that become? 10 to the 17th, and then I just need to multiply the other two numbers. 9.4 times 7.2. So I get 67.68 times 10 to the 17th. But this is one where I was talking about the decimal place needs to be right here after the first 6, so I need to move it 1 this way. So what happens to this number when I do that?
To the 16th power? No, 7th.
Other way. Yep. 18th. So 6.768 times 10 to the 18th. Because the higher number means I'm going to be moving it to the right to make it a bigger number. 22. 1.1 times 10 to the negative 3 over 5.5 times 10 to the negative 8. Now, I should go back on 16 for a second and specify the only time it's okay to have negative exponents is in scientific notation. Okay, otherwise we need to make them positive, but scientific notation, we would leave it that way because that tells us that the decimal place is moving to the left. I don't know if that's what you were trying to ask when you said something about making it a really small decimal, or if you were just trying to like get rid of the 10 to the power or whatever altogether. But all right, so on this one, we're going to move everything to the top because scientific notation, we'd want everything on top. So I'm going to move the 10 to the negative 8 up here. So what I'm going to end up with is 1.1 divided by 5.5, and I'll have to figure out what that is in a second, times 10. We add the 8 up here, so this would be 10 to the 5th.
Wait, did you say add?
Yeah, put it where it ain't, make it positive.
Oh,
So we would add it up here to get rid of it. What's this?
0.2.
Wait, 0.02? Is that right? Question,
You're
my
supposed
bad.
to move the decimals. 'Cause there's a decimal on both.
Gonna be honest, it's been a really long time. It is 0.2. I moved one of them. Ah, come back. It's been a hot minute since I've done decimals this way, so.
yeah, I was about to say, aren't you supposed to do the decimal points, though?
Yeah, I needed to move it over too. So this would be 0.2 times 10 to the 5th.
But do you need to move the thing? Do you need to move anything? So
Or are you saying in the final answer? Yeah. So move it this way.
2 times 10 to the 4th.
Yep.
Ah.
So the decimal has to go after the last number.
Stop
Okay. Simplify the expression. It says, again, tell which properties you use. We don't need to do that. Obviously, you kind of have to know which properties you're using or you're not going to get the answer right. So, 24. I just don't see a point in you writing the names. W to the negative 2 over W to the 6th. So anytime I have something like this, I need to move it. But if I move the 6 to the top, then I'm going to end up with a negative exponent, which I can't have, so then I'm going to have to move it. So I'm moving the negative 1 to the positive 1. So that means I'm moving top to bottom on this one. And so we end up with 1 over W to the 6 plus 2, so W to the 8th.
Oh.
26. In the parentheses, P cubed, Q squared, all to the negative 1. What happens with this one?
Carry the
Yep, so I would have P to the negative 3, Q to the negative 2. Am I done?
No, I'm gonna make a fraction.
Yep, I need to move them both to the bottom because they both have negative exponents, so 1 over p cubed q squared. X to the negative 1 y squared over x squared y to the negative 1.
Don't you need to move the y up and the x down?
Yep.
Good job.
So on top, we add the 1, we'd get y cubed.
Over x.
Over on the bottom, yep, x cubed. (32) 4r to the 4th s to the 5th over 24 r to the 4th s to the negative 5th. Yeah, so basically this is just like normal fractions as far as the numbers go. We would reduce the numbers if we can. So 4 goes into 24 how many times?
6.
And then up here, essentially we have r to the 4th over r to the 4th, which is just what? 1, because technically we can subtract the exponents until we get r to the 0, which is 1, but that's just going to go away there. And then what do I need to do with the s's? I have s to the 5th on top and s to the negative 5th on the bottom.
Add the s to the top.
Yep, add that one to the top, so we'd get s to the 10 over 6. One more. 34. Y to the 11th over 4z cubed all times 8z to the 7th over y to the 7th. All right, so I'm going to tell you ones like this people tend to struggle with the most because they're like, but I can't just like cancel anything top and bottom, but I'm multiplying, right? So everything on the top of both fractions is multiplied by each other and everything on the bottom. So if for yourself, if you need to see it by combining it into one fraction, you can. I usually don't because I'm used to just multiplying fractions. So the 4 and the 8, what happens to that? Yep, this 4 is going to go away. This one's going to become a 2. And then I've got y's here. What am I going to do with the y's?
Cancel them out. Wait a minute.
Subtract the y 4 to the bottom.
This is the 11th.
Pause.
Oh, that says 11? Oh, sorry, that's like a 4. Oh.
So I'm going to subtract the 7 from that.
It looks like a 4 from.
So I'm going to go ahead and write my 2 up here. And so then we have y to the 11 minus 7, which is y to the 4. And then what about the z's?
Subtract from the bottom. So,
Yep. So z to the 7 minus 3, which is z to the 4th. So there ends up being nothing on the bottom.
The 4 kind of looks like the 11. Sort of.
Except for there's a gap between them.
Yeah.
Well, yeah, whatever.
I can see why from over there it would probably look like a 4. They're kind of close together. All right, any questions on this? Hopefully this is mostly a review, maybe aside from scientific notation. You probably did a tiny bit with scientific notation in Algebra 1, but like very, very briefly.
This is the math.
No, I remember a lot.
This is
Scientific
cool.
notation.
From
That
science
chapter
class or
was-
from
Was
Now
that
for
last
math.
year? though?
math?
No, that was in algebra.
Oh.
Because remember, her mom writing with her left.
Oh yeah.
Was that when she had her surgery?
Yeah.
Couldn't remember because she had her shoulder last year, but I couldn't remember when she had it. Her hand. All right, so 3, 7, 11, 19, 23, 25, 31, and 35. So you should have more than enough time to knock this out now and not have to worry about it over the weekend. We will do, I mean, I think y'all pretty much will have this down, but we will do a little bit of review with this stuff before you would take the quiz on this stuff next week. So just be aware of that.